heard of inverse functions before? Victoria, keep your earphones off. Devin, earphones off. Yes or no? Anybody? Remember hearing about inverses? No? Do not recall. And that's fine if you don't. I'm just wondering if you have. Now, how do you prove that two functions are inverses of each other? Something that we covered in the previous section. Show that f of g of x, remember seeing that before?
Yes.
Equals to x, and g of f of x equals to x. If you could show that both of those are equal to x, then you should be able to prove that they are inverses. So what in the world does that mean? I'm going to do one with you, and then you're going to do one on your own, and then we're going to share answers. So, here it goes. I can't even spell. Verify. My goodness. Verify. They are inverses. Here's the first one we need to verify. They're going to give you f of x equals 3x plus 2, and g of x equals x minus 2 over 3. So you have two parts to verify here. That f of g of x is equal to x, that g of f of x equals to x, which means what to you? I have no idea. So we're going to split this into two. I have to do this, and I have to do this. And this notation, we covered it last time in 2.6, composition of functions. So, is everybody caught up already? This means f, who's g of x? X minus 2 over 3. Very good. Now, who do I plug in x minus 2 over 3 for? The x is an f. So function f is 3x plus 2. But what do I plug in here? X minus 2 divided by 3. It's like if I had the number 4, then you would plug in a 4 for every x in there. But in this case, we're going to be plugging equations. Questions right there. Now, if I had to multiply this, or how would you solve this? There's two ways. I don't know which way you would rather do it, but which way would you realize you could do this in? What happens with these threes? They cancel, exactly. Those go bye-bye, so what do you have left over? 2 plus 2, don't forget about that, plus 2, but what happens with this minus 2 plus 2? And this is just what? X. So, did I prove it was x? Yes. If you end up with an x, more than likely they are inverses. You have to do it the other way around also. So this now becomes g. Who's my f of x?
3x plus 2.
And who do I plug in this 3x plus 2 for? Every x in g. G of x. So I have x minus 2 divided by 3. Who do I plug in for the x?
3x.
3x plus 2. So when I look at that 3x plus 2 minus 2 divided by 3, what can I do? No, not yet. No. Before that.
2.
Because this is just 3x plus 2 minus 2 over 3. If we remove the parentheses, because the parentheses doesn't do anything, what happens to these two? Cancel. So what do you have left over? 3x over 3. And 3x over 3 now just becomes what? So I just proved, I just verified that they are inverses of each other because I ended up with x. So your question on your assignment is going to say, are the following inverses? Yes or no? So the answer for this one would be yes. So here's one for you to try on your own. Consider it a DIY or you doing one on your own. F of x equals 4x minus 7. And g of x equals x plus 7 over 4. So go ahead and do both scenarios. F of g of x and the g of f of x. I'm going to pause this and you guys work on it. Come on. You can pause it. Okay, let's go ahead and get started. So, I went ahead and I already substituted the g of x with the g of x. We plug it into every x into the function. What happens to your 4's?
Cancel.
They cancel, they cross out. So then we have x plus 7 minus 7, which becomes
X.
x. So we're done there. Then we have g, f of x is 4x minus 7. We plug this in for every x in g. So I have 4x minus 7 plus 7 over 4. The 7's, what happens to them?
Cancel.
They cancel, so we have 4x over 4, which is just
X.
x. So are they inverses?
Yes.
Yes, they are. So that's how simple that is. That's just so you understand what you're doing. That's going to be for question number 1 and number 2. 1 and 2 on your assignment, you're going to have to do that. Good luck to you. Question 3, 4, 5 are like the following. So, how do you find the inverse? So, to find the inverse, you switch the x and y variables, then solve for y. That's how you find the inverse of an equation or of a function, basically. They're going to use this notation f of negative 1. This negative 1 means inverse of f of x. So for example number 2, find the inverse of the following. We have a couple examples here, but we want to make sure we touch every different version that you could have. If I give you f of x equals 7x minus 5. That's the first one. So the first thing you need to understand is f of x means what? F of x is the same thing as what other variable?
X.
Y. So this is the same thing as y equals 7x minus 5. Are we okay with that? Yes? The rule says in order for you to find the inverse, I have to switch the x and y variables. So what does that mean? This now becomes a what?
X.
X. And this now becomes a
Y.
y. You're not changing the numbers, you're just switching the x and y. And then you solve for y. How do I solve for this y here?
Plus 1.
Plus 5, very good. So we add 5, we add 5. X plus 5 equals to 7y. And then what do?
Divide by 7.
Divide by 7. So then y equals x plus 5 divided by 7. And there's your answer. That's how simple that is. That should be a y. How bad is that?
Not bad.
Not bad? Easy? Okay, so what would happen if I had something like this? Y equals x cubed plus 1. So what's the first thing I have to do?
Switch the X and Y.
switch the x and y, so this becomes x equals y to the third plus 1. So I'm still solving for y. Who do I move first?
The one.
The 1, so we subtract 1, so I end up with x minus 1 equals y cubed. How do I get rid of that y cubed?
Cube root.
The cubed root. Very good. So I take the cube root with a little 3 there and the cube root here. So then this is just the cube root of x minus 1 equals to y.
Y.
Now we could rewrite it the other way because that's the way we're used to seeing it. Cube root of x minus 1. Both things are inside of the cube root. Excellent. So not so bad, right? Try C on your own. It's another cube root, and the only reason I'm giving you another one is because one on your assignment will be with the cube root. So try to do that one on your own. We're going to start working on it. Pick up your head and look at the answer once you are done. What should I do here first?
Divide by 4.
Divide by 4 is correct. So I'm going to rewrite this way. I like to see my y's on the other side. So what do we do still here? Cube root. Cube root. Cube root. So y equals the cube root of x plus 1 over 4. Number 5, something like this. The last one in this section is going to be y equals 5 over x plus 4. It's a little bit different, it's not impossible. The first thing we should do is
Subtract. Oh wait, no. Switch the.
switch first. Now the y is your denominator, so it makes it look a little bit weird. Maybe you're thinking it's going to be a little bit difficult, but it's not. What do we do?
Subtract 4.
Subtract 4 is correct. Subtract 4. X minus 4 equals 5 over y.
Don't you do it by the reciprocal?
We can multiply by the reciprocal, that's fine. What
Or
happens when
5.
when you multiply by the reciprocal, you're gonna end up with nothing over here. So my recommendation is you first multiply by your denominator. So when I multiply by my denominator, I multiply this by y, and this by y. Now, what happens to your y's here?
They cancel.
So I end up, and I'm not gonna multiply, I'm just gonna leave it like this, because that's good enough, so my answer is just a 5 right there, right? Now, you're trying to solve for who? Y. Y is being multiplied by this, and who is that I need to get rid of? This. So if it's multiplied, how do you get rid of this? Divide. So, and that's your final answer right there. So we divide by x minus 4, divide by x minus 4, y equals 5 over x minus 4. So even though it's a variable in the bottom, you still just multiply by the denominator. That crosses out. Would you like to try another one like this? Or do you think you got it?
Another one.
Another one, just to be on the safe side. Y equals 3 over x minus 1. We'll start working on this one. I'll start it in a little bit. Do you agree with this answer?
Yes.
Yes? Perfect. There it goes. Alright. So, next part. There's an F actually. Y equals 2x plus 1 over x minus 3. 2x plus 1 and x minus 3. See if we could figure out what's going on here. First thing is this becomes x equals 2y plus 1 over y minus 3. Do we agree?
Yeah.
Yes? Then how to, or what do I do?
You like split the two. Like
What did I do here? I multiplied by the what?
y.
Because it was my denominator. So here I have to multiply by my denominator, which is this. So we're doing the same thing we did over here, it's just a little bit longer. Now these guys cross out. This becomes x parentheses y minus 3 equals 2y plus 1. 2y plus 1. Are we okay up to right now? Yes? So, for this section, which is problem number 6, you do have to multiply. This becomes x what? xy minus 3,
Right.
x equals 2y plus 1. If I am trying to solve for y, and I look at this side,
Subtract.
I subtract 1, very good. So let's subtract 1, subtract 1. So this becomes xy minus 3x minus 1 equals to 2y. Now, who from here belongs on this side because it has a y?
X, y.
So we're gonna subtract xy, subtract xy, negative 3x minus 1 equals 2y minus xy. Now, what can I do? What did both of
Divide.
these have in common? A y. Have we covered factoring? Yes? So I should be able to factor out a y. When I factor out a y, what's left over?
2.
2 minus that.
2 minus x. So what can I do now?
Divide by 2.
Divide by 2 minus x, divide by 2 minus x. That crosses out. So my answer is y equals negative 3x minus 1 over 2 minus x. The only thing is your G for Gabby. I'm just kidding. 2x minus 3 over x plus 1. 2x minus 3, x plus 1. So try to do this one. Take a good 2-3 minutes because I'm gonna not work it out so we could work it out together right now. At the very end, yes. Anytime that you have a variable on top and bottom, you always do that. You guys almost done? Let's start going over it or no? So, and I already wrote it wrong. This should be a y on the bottom. If we write this, please make sure y's become x's, x's become y's. What would be the first thing I do?
Multiply by y first.
Multiply by my denominator, which is y plus 1. These cross out. X parentheses y plus 1 equals 2y minus 3. For these problems, I do have to distribute. So this becomes what?
X, y
plus x, right? And who would you move first?
Add 3.
Add 3, so it's going to be the same steps for your thing. xy plus x plus 3 equals 2y. But who should go to the other side? Subtract xy, very good. X plus 3 equals 2y minus xy. Factor out y. So we end up with, and then divide by this, divide by how do we do that? When you have a table of values, and you need the inverse, you switch your x and y values in the table. Okay? So what in the world does that mean? Number 7 on your assignment is going to be like this. Make the inverse. F of x equals x squared minus 1 when x is greater than or equal to 0. So remember we talked about limits when we did piecewise functions. So this is a little bit like that. It only tells me we care about where it's 0 or greater. So if I were to graph this, I'm just going to do a sketch here, and x is 0. FYI. If I plug in a 0 here, what's 0 squared? Minus 1? Negative 1. If I plug in a 1 there, what's 1 squared? Minus 1? 0. Let me plug in a 2. What's 2 squared? 4. Minus 1? 3. So I'm just going to sketch these points. That's it. So I have 0, negative 1, which is here. So, continuing on this one, I was going to sketch 2, 3, which is there. So my graph, my parabola, we're just talking about that part, because the only one where x is greater than or equal to 0. But I need to find the inverse. We do it the same way, because I do need the equation and the graph part. So, this is y equals x squared minus 1, but what should I do?
Switch the x and y.
Very good. So what do I do here?
Add 1.
Add 1. X plus 1 equals 2y squared. And then I must do what?
Square root.
Take the square root of both sides. So y equals square root of x plus 1. Now, why do I need a table? Because there's no graph given to you for this problem, but taking into consideration what I wrote up here, when you do the table of the inverse, what is the only thing that it says that you do? You switch your what?
X and y.
So my first point here is going to be what? 0, 0, 1, and 3, 2. That's the first thing right there. So when I sketch this new graph here, negative 1, 0 is there. 0, 1 is here. And 3, 2 is about there. So this graph goes something like this. So this might be easy, but now I still have to give a condition like this. Does this graph start with x is greater than 0, or where does it start?
X is less.
greater than or equal to who? Negative 1. So that is the only thing that we need to be careful. So okay, this along with x is greater than or equal to a negative 1 because of my new starting point for this one. So this is going to be like number 7 on your assignment. And believe me, if your notes are out when you do number 7, this answer should be correct when you work on it. Are we good? So, continuing on to example 4, a couple of notes that you need to know. Here it is. Any inverse on a graph reflects over y equals x. The next part, problems 9, 10, 11, 12, and 13, they're all graphing problems. So we need to know how to graph and what it causes when we're graphing, when we're finding the inverse. So any inverse on a graph must reflect over y equals x. In case you don't know what y equals x is, it's just a straight line that goes something like this. But I'll let you copy that down, and we're actually going to go back to example 3 so we can see if there is actual reflection over that. And there should be. Are we okay? So for number 9, they're going to give you a graph, and you have to find the inverse of it. So my recommendation to you is get 2, 3 points on the graph, and do what we did in the previous example. Which point is this? Negative 3, 1. Which point is this? 0, 2. And this one is 3. So if I find the inverse, my new points are going to be what? 3, 2, 0, and 3, 3. So when I sketch this, 1, negative 3 is going to be here. 2, 0 is there, and 3, 3 is there. And if I were to draw a line, and if this graph were precise and exact, does it reflect on y equals to x? Yes, it should. It should reflect right there. Any questions on this? Questions, 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 questions? No? Alright, let me just kind of go back to this one. You see this? If I were to draw a line through here, and this is y equals x, does it reflect, like if I were to fold it in half, would it reflect?
Yes.
Yes. So that's what I need you to do when you look at your graph. You're like, does it even reflect there? No, so then it shouldn't even be the case. So, example number 5. Let's look at this. How would you graph this on a paper? And the reason I say how would you graph it is because you won't have a calculator, so you have to know how to graph this on paper. So the first thing is pick points. So which points would you pick? Smallest one. So let's try a negative, a positive, and a negative. Let's do negative 1, positive, 0 and a positive 1. How do we do that? How about, let's do that. So negative 1, 0, and 1. When I plug in a negative 1 here, what's 2 times negative 1?
Negative 2.
Negative 2 minus 1?
Negative 3.
Negative 3. If I plug in a 0 here, 2 times 0? 0 minus 1? Negative 1. And if I plug in a 1 here, 2 times 1? 2 minus 1? 1. So let's go ahead and try to sketch these points. And we're going to make the best out of it. We don't have graphs. Today in the morning I had to turn in calculator, so we're working with what we have. Negative 1, negative 3. 0, negative 1, and 1, 1. I look at this, and this is my line. What is the domain and range of any line? Domain and range of any line is going to be what? Does it ever stop? Negative infinity to infinity. Negative infinity to infinity. That's your domain. And the reason I'm throwing that in there is because it's going to be as part of your answer. Now I have to graph the inverse. So for inverse, what do? Switch x and y. Negative 3, negative 1. Negative 1, 0, 1, 1. So when I graph this line, negative 3, negative 1, negative 1, 0, and 1, 1, my line looks like this. Now, remember, does this line reflect over x, y is equal to x? Yeah. Yes, it does. So there it is. Now, does my domain and range change for this new line? It is still a what?
Negative infinity.
It is. So negative infinity to infinity, range is negative infinity to infinity. So it doesn't change. Nothing wrong there. That's going to be very much like number 10. You should be able to do the other ones. I'm only going to do one more with you because it's the only one that's different. So part B here, let's say we had f of x equals x minus 2 squared, where x is greater than or equal to 2. And that's the only reason I'm doing this one is because they give you a limit. So, looking at this, I should know if it's squared, it's going to be what kind of shape? A parabola, a quadratic. Now, but they say I could only use what? Numbers greater than who? 2 or equal. So I'm going to put 2, 3, and 4 and just work with that. So when I plug in a 2 here, what's 2 minus 2? 0 squared? Still 0. What's 3 minus 2?
Negative 1.
1. It's a positive 1. 1 squared is 1. What's 4 minus 2?
2.
2 squared?
4.
4. So I sketch this 2, 0, 3, 1, and 4. So this graph should be kind of curving up like this. But because I'm looking for the inverse on a graph, my inverse table now is going to be what?
0, 2,
0, 2,
1, 3.
and 4, 4. So 0, 2, right there. 1, 3, right there. And 4, 4, right there. It's going to look something like this. Is this reflecting over this line? It sure is. The only thing I need you to be careful with this one is my domain and range. So my domain for this problem, which is this graph, where does my x start because of what the limitation it gives me? My domain
2.
starts where? At 2,
2.
right? So it goes from 2 on to infinity. For some weird reason, they don't put the bracket. They're going to be using the parentheses, but it should be a bracket. But they're using parentheses in your assignment. They messed up. And what is my range for this one? Does it occur into the negative? 0 to infinity. What's the domain and range of my new graph? So my domain is now where? 0. So it goes from 0 to infinity. And the table helps you. And how about your 2 to infinity? Very good. So it starts off here. This is x is 0, and it goes this way. This is y is 2, and it's going to go up. So it's 2 to infinity. This is where you need to be careful, and this is number 11 on your assignment. All the other ones, if you do tables and you plug it in and you work with it, you should be able to do it.
This is number.
With something in my face?
No, I had to listen to this one, I think.
Okay, actually, you know what? I do have to do one more. So then we're gonna think. Alright. X minus 5. Square root of x minus 5. I'm burning up here.
Yeah, now it's hot.
So, x minus 5. Do they give you limitations?
No.
No. So we're going to start off with what? Can I have a negative inside? No. So I should start off with what number? If I put a 0 here, I end up with a negative 5. If I put a 4, negative 1. But what happens when I put a 5?
0.
0. So I could start off with a 5. 5 minus 5, square root of that is 0. What happens when I put a 6? 6 minus
1.
5, 1. Square root of 1, 1. And that should be a good idea. Because if I put a, what would it give me a 4 inside?
9.
A 9. So 9 minus 5 is 4. The square root of 4 is
2.
2. So that's all I need for right now. Let me make the inverse of the table. And this becomes what?
0, 5.
0, 5, 1, 4, and 2, 9. So when I sketch this, my graph starts at 1, 2, 3, 4, 5. 5, 0. Then it goes 6, 1, 7, 8, 9. Now, knowing how to sketch this one is going to give you at least something where you could, let me see, did I bring one? Yes. So look at this, just so you see. When I look at this, it's like, look at the word sketches, look at where this sketch, and this is sketch, and this is sketch. So it should help you eliminate at least 1 or 2 answers. Now, when I graph the new one, 0, 5, 2, 3, 4, 5, 0, 5 is up here, then I have what? 1, 6, and then 2, 9, and my graph is going to go this way. And it looks like kind of crazy, but if we had the line here, this, it would reflect on the y equals to x. So it's just a little bit different, it looks a little bit odd, but it still works, it just depends on where it's at. So, are we good? You're going to make the best out of this because you guys are awesome people. Alright, that's it. I'm done. Breathing. So, you can't see the graph, but the graph is coming from here and it's going up. It starts off at 0, 3 and it goes up for A. For C, it starts off at a negative 3 and it goes up right there. So for C, it starts off at a negative 3. For B, it says there is no inverse, so there is no other graph. For D, it starts off at 0, 3, and it goes like this also. So it's like C, but the difference between C and D is where the original one starts. Are we good? Alright. What do you think the answer for number 8 is? And here's the free answer.
8. Yes.